Hello everyone. Today I'm going to present our paper, a dynamic GPU power prediction framework for production HPC applications. So power consumption of next generation HPC systems is increasing, and there is a common trend of hardware over provisioning in HPC, such that you deploy more compute capacity than your power budget allows. So in such cases, HPC systems have to operate under power constraints, and we need power management methods to effectively use the limited power budget. So in this context, accurate predictions of power consumption is crucial to assist those dynamic power management frameworks. And in this work, we propose a dynamic GPU power prediction framework for production HPC applications. We collect data sets of 5 common HPC applications in Perlmutter supercomputer and one application agnostic dataset that basically consists of DCGM telemetry of the system. So our models have two different knobs. One is the feature set that they are using. Multivariate models use the DCGM telemetry that includes power consumption and other metrics, and univariate models only use historical power consumption data to predict future power consumption. And we have generic and application-specific models. Generic models are trained on the application, the agnostic data sets, and the application-specific models are trained on the corresponding application data set. And we use LSTM models to predict future power consumption in multi-step predictions. So we have three different predictions, and we are predicting the power consumption over the next 30 seconds, and we are looking at the historical data of the last 2 minutes that includes DCGM metrics and the power consumption to predict the future power. So quick look at our results. We see that our application-specific models improve the root mean square error by up to 48% compared to generic models and beats the baselines that we have. And in this plot, we see the timeline of predictions and actual power consumption for a chroma job. So as we can see, application-specific models accurately predicts the power spikes that repeatedly happens in this application run, but the generic models are lagging and are not able to predict the power spikes properly. So to summarize, we propose a machine learning-based approach for runtime GPU power prediction designed for real-time deployment in mind. So we are using lightweight telemetry data with DCGM, and we have a lightweight model selection with LSTMs. And our application-specific model training approach reduces the prediction error by up to 48% compared to the generic models. And we see that incorporating DCGM metrics reduces root mean square error by up to 15% compared to the models that use only historical power consumption. Feel free to contact us if you have any questions about the paper.